graphs and networks. So graphs and networks are basically a simplified version of a real life scenario. So for example, it might be simplifying a map between towns, or it might be simplifying a site map where the vertices might be buildings. It could represent a wiring network or so on. So in each graph or network, we have the little dots are called vertices or nodes. The lines are called edges or arcs. The spaces in between the lines are called a face. So you can see here I've got a face in the triangle and a face in the circle, but the outside area is also a face. So keep an eye out for those. They're usually the ones that people miss. Now there's a whole lot of terminology you need to get familiar with, so we'll start with some of those. So first we're going to use the term adjacent vertices. Now those are vertices that are connected by an edge. So in the diagram above you can see that A and B would be adjacent because they're connected by an edge. A and C would be adjacent because they're connected by an edge. B and C would be adjacent, and C and D would be adjacent. Okay. Multi-edges are where we have more than one edge between one pair of vertices. So here you can see that the vertices A and B have multi-edges because I've got the two edges that run in between them. C wouldn't be. It's got two edges coming in, but each edge is coming from a different vertex. So only A and B in that example have what we call multi-edges. The degree of a vertex is the number of edges touching it. So in that diagram above, A has degree 3 because there are 3 lines coming into that. So you can see here I've got those 1, 2, 3 lines coming in. B would be of degree 3 also because I've got the 1, 2, 3 lines coming into that. And C would have degree 2 because there's 2 lines coming into that one. Now we also talk about in degrees and out degrees, and they are only relevant if we have directions on our vertices. So I'll just put some on for the moment and you'll be able to see. So if I put some directions, some arrows onto my line showing which way I can travel, well then I would have different in degrees and out degrees. So now looking at vertex A, I've got an in degree of 2 because I've got 2 lines that come in, and I'd have an out degree of 1 because there's 1 line coming out. B would likewise have an in degree of 2 because I've got 2 lines coming in there, 2 edges, and it would have an out degree of 1 because I've got that 1 line coming out of it. C would have an in degree of 0 and an out degree of 2 because I've got the 2 lines coming out of there. So that's the in degrees and out degrees. They're not super important, but you should be conscious of them. The other thing we talk about, which is sort of related with the vertices, is the order of a vertex. And the order of a vertex is whether it's odd or whether it's even. And we're talking about, is there an odd number of edges coming into that vertex or attached to that vertex, I should say. That doesn't matter if they're coming in or out, but it's just, is it odd? Or is there an even number? Now this is going to be important down the track to work out whether a network is traversable and therefore also whether it is Eulerian. So if we looked at this graph again, A would be an odd vertex, and I get into the habit in my diagrams of circling the odd ones because it is an important concept that we tend to use a bit. B would also be, oh pardon me, so I'll turn this noise off. Sorry. B is also an odd vertex, and C would be an even vertex, and they're going to be important concepts for us. Okay. And then we've got adjacency matrices. I might do that in a separate video.